Good morning to all of you. In this lecture, I will discuss about the concept of electric dipole. What is electric dipole? What is its unit? What is its dimension? And how to find out the electric field due to a electric dipole in different situations. And I will also discuss few examples based on this concept. So the first question is, what is electric dipole? So electric dipole, it is an arrangement of two equal and opposite point charges which are separated by a distance, certain distance, let's say 2d. So this is the representation of electric dipole. So this figure represents the electric dipole moment arrangement, in which this is minus charge, this is plus q charge, which are separated by a certain distance 2d. So it is represented by a letter P, which is Q cross 2d. So Q cross 2d. Its unit is coulomb meter, and you can write the dimension. I just leave it to you. So what is the dimension? So this is the way to represent the electric dipole. There is another definition of electric dipole. An electric dipole is a pair of point charge with equal and magnitude but opposite in direction and separated by a distance. So this is the way to define the electric dipole. Now next we will discuss about the calculation of electric field. Electric field due to electric dipole in different situations. So in this lecture I will discuss the three different situations in which we will write the expression of electric field. So the first one is electric field due to a dipole at an axial point. So E field due to dipole at an axial point. It means we have arrangement of electric dipole in which this is, let's say this is electric dipole, this is minus q and this is plus q, which are separated by a distance 2d, and we want to find out the expression of electric field at any point P, which is at the axis of this dipole. That is why we are saying this is axial point. Axial point means this is the axis of dipole. In this axis we want to find out the electric field. So we consider any point P which is at the axis of this dipole, and we want to find out the electric field. So this point and this distance, and from where we want to find out the electric field? From the center of the dipole. From the center of, let's say this O is the center of this electric dipole. So its distance from the point P is R, and if this distance is 2d, then distance from O to this charge, let's say this is A and this point is B. So this is simply D, this is also simply D. So what is the electric field due to this plus charge and this minus charge? So electric field profile due to this plus charge is, let's say E1, which is in this direction, and electric field due to this minus charge, let's say this is E2, which is towards the charge. So this is the schematic through which or by which we can find out the electric field due to the electric dipole at an axial point. So we have two different field, and total field is sum of this two field, E1 minus E2. E2 is in opposite direction, so minus minus becomes plus, and we can add. So this total field is E1 plus E2. Now what is E1? We know what is the expression of electric field due to the point charge. In this case, we have what is the electric field? E1 is the electric field due to this plus charge. So 1 upon 4 pi epsilon 0 q positive by distance. And what is the distance of this plus charge through this point P? So total distance from the center of dipole, this is r, and this distance is simply r minus d. R minus, total is r, and this one is O to B is this one. So total distance is r minus d. So this distance, this BP, in another way we can write it as this BP is the distance from point P to this charge, plus charge Q. So BP is basically OP minus OB. So this distance, what is your interest? This is BP square. So we can write it as, this is r minus d. So this 1 upon 4 pi epsilon 0 q by r minus d square. This is the electric field due to positive charge. Electric field at any point Q due to this. Now what is E2? E2 is the electric field at point P due to this minus charge, negative charge. So again this is 1 upon 4 pi epsilon 0 q by r plus d. This distance is this one is r and this one is d. So this is r plus d, and we can either we can write it as this is AP. So r plus d square. And so from equation we can conclude that whether E1 is greater than E2 or E2 is greater than E1. What is the proportionality? The proportionality in this case, E1 is proportional to 1 by r minus d, and this is denominator term. If this is small, then this is large. If this is large, then this is small. And here E2 is proportional to 1 by r plus d, square of r plus d. So r plus d is larger, so E2 is smaller. So we conclude that E1 is greater than E2. So this is the statement question. If we have this situation, then what is the magnitude of E1 and E2? Whether E1 is greater than E2, corresponding to this figure, what is the situation? E1 is greater than E2, or E1 is equal to E2, or E2 is greater than E1. So in this figure, in this situation, we have E1 is greater than E2. So now rearranging, after putting the value of E1, E2 and rearranging, we have an electric field profile due to electric dipole at an axial point is simply 1 upon 4 pi epsilon 0. I think it is not visible, so let me write here. So electric field is 1 upon 4 pi epsilon 0 p by r cube. This is 2p by r cube. So this is the profile corresponding to this situation at an axial point. At an axial point. So next we have the electric field due to equatorial line. Electric field due to a dipole at an equatorial line. Electric field due to an electric dipole. Second, we have electric field due to an electric dipole at a point on equatorial line. So what is equatorial line? So again we have electric dipole. This is minus, this is plus q. Separation distance is 2d, and we want to find out the electric field. So we have to find out, or we will find out the electric field at equatorial line. So equatorial line, basically the perpendicular bisector of the line joining the charges. So this one is the perpendicular bisector which divides this line equally. So this is equatorial line, and we want to find out the electric field at this. So this is due to plus charge, this is due to minus charge, and this one is E1, and this one is, because this is positive charge, so electric field is away from this charge, and this is negative charge, so the electric field direction is towards the charge, and this one is electric field at this point, and we want to find out this. So in this situation, and this distance is d, this distance is d, and this distance is, let's say this is r, and so this distance is square of this under root is r square plus d square. So by this is simple geometry, 10 plus 2 are 10th class geometry. So with the help of this geometry, we can find out the electric field at this point P, which is E. So after doing calculation, we have so for a competitive examination, what is our interest? Our interest is to find out the final expression and look at the variation of electric field with distance. Okay. So after doing calculation, we have electric field profile, which is E equal to 1 upon 4 pi epsilon 0 P by R. In earlier case, we have 2 P by R, but at equatorial line, so electric field due to electric dipole at a point on equatorial line. So equatorial line means the line which divides the line joining this dipole perpendicular bisector. This line is equatorial line, and we want to find out the electric field at this point P. So this is EP, which is 1 upon 4 pi epsilon 0 P by R cube. Next we have electric field due to this electric dipole at an angle. Third, at an angle. Means there is an angle between the dipole and electric fields. So in that case, let me draw the geometry. Dipole at an angle. So again, we have a dipole which is minus q. This is plus q, which is separated by a distance 2d, and we want to find out the electric field at this point P, and this angle is theta, and this is P cos theta, and this one is P sin theta, and this is the direction of dipole. So in this case, electric field due to electric dipole at an angle, if there is an angle, so the direct expression is E equal to 1 upon 4 pi epsilon 0 P by R cube under root 1 plus 3 cos square theta. There is separate derivation which is very easy and easily available in all textbook of electricity and magnetism. So you can reach it. So we have three different profile of electric field due to electric dipole, which is the first one is at an axial point, second at an equatorial line, and third one at an angle. So in all these cases, we have electric field is directly proportional to 1 by R. This is the conclusion. and in this case, electric field depends upon the r, p and theta also, and r and theta also. So this is the difference between at an angle and electric field to electric dipole at an angle situation and equatorial and axial point situations, and this is the way to define the electric dipole. Next we will discuss about the examples, how to deal with the problems which is based on the concept of electric dipole. So the first example is a dipole consisting of an electron and proton comma 4 into 10 to the power minus 10 meter apart. Calculate the dipole moment. Calculate the dipole moment. So in this example we have information about the separation distance and charge on the system. So we have electron and proton. So given that from this example we have given that, this is Q, charge is electron which is 1.6 into 10 to the power minus 19, charge on electron or proton is this much amount, and what is the separation distance? Separation distance which is 2d, which is 4 into 10 to the power minus 10 meter. So it is in MKS, it is also in MKS. So, and the expression of dipole moment is Q into 2d, which is 1.6 into 10 to the power minus 19 coulomb into 4 into 10 to the power minus 10 meter. So this one is 6.4 into 10 to the power minus 29 coulomb meter. So this is the most simplest example which is based on the concept of calculation of electric dipole moment. Next we have a dipole. Next example. A dipole consisting of an electric field, electron and proton, that is same example. A dipole consisting of electron and proton which are 4 into 10 to the power minus 10 meter apart. Compute electric field at a distance of 2 into 10 to the power minus 8 meter on a line making an angle an angle 45 degree with dipole axis from the center of dipole. So what we have to do, and what we will do, we have information about charge, we have information about separation distance. So in earlier example, we have already solved the dipole moment with the help of this separation distance and charge. Charge on electron and proton is 1.6 into 10 to the power minus 19 coulomb. And in this example, we have to find out the electric field due to a dipole at an angle. At an angle. So we know the formula: electric field due to dipole at an angle, which is E equal to 1 upon 4 pi epsilon 0 P by R cube 1 plus 3 cos square theta. So we know what is P, what is the value. This is well known constants. Its value is P is Q into 2D, which is we have already solved. Q is 1.6 into 10 to the power minus 19 coulomb, and D is 4 into 10 to the power minus 10 meter, which is 6.4 into 10 to the power minus 29 coulomb meter. And what is R? R is 4 into 10 to the power minus 10 meter. And what is the value of this? 1 by 4 pi epsilon 0, which is 9 into 10 to the power 9 Newton meter square per coulomb square. And what is theta? Theta is 45 degree, which implies that what is our cos theta? Is cos 45, which is 1 by root 2. So cos square theta is 3 by 2. So cos square theta is 3 by 2. Now putting all the entity in this expression in order to find out the electric field due to a dipole at an angle. 9 into 10 to the power 9 into P is 6.4 into 10 to the power minus 29 by R cube, which is 4 into the separation distance is 2 into, this is the separation distance, 2 into, sorry, in this case this is simply 2 into, okay, this is the distance R, which is this one. Let me recorrect it. So R cube is basically 2 into 10 to the power minus 8 cube into 1 plus 3 cos square theta, means 1 by square of 1 by root 2. So what we have? We have 9 into 10 to the power 9 into 6.4 into 10 to the power minus 29 divided by 8 into 10 to the power minus 24 into, this is 3 by 2, this is simply 5 by 2. This is simply 5 by 2. So after simplification, we will have the electric field profile, which is 1.138 into 10 to the power 5 Newton per coulomb. 10 to the power 5, or in another way, let me write it here. So this is, so after calculating, we have electric field is 1.138 into 10 to the power 5 Newton per coulomb. This much amount. So this is the way to find out the electric dipole moment and electric field due to a dipole in different situation. This is the situation of at an angle. So just this is the formula for electric field due to a dipole at an angle. Now putting all these value and solving, we will have the profile of electric field. So it's all about the electric dipole. In next lecture, we will discuss about few more examples based on the calculation of electric dipole. Thank you.